Okay, in this problem we're asked to find the region that's common to these three inequalities. So first of all, we've got to graph the boundaries for each of these, which means we've got to consider the inequality symbols as equal signs, treat these as lines, and graph those lines. Those will be the boundaries. So in the first one we get y is equal to -1. That is a horizontal line through -1 on the y-axis. So there's my boundary line there. Y is equal to, or y minus 2x is equal to 3. If I add 2x to both sides, that gives me y is equal to 2x plus 3. That means it's got a y-intercept of 3 and a slope of 2, so I graph that, y-intercept of 3 here, slope of 2. And I graph that boundary line. And then this one is x plus y is less than or equal to 6. If I subtract x from both sides, I get y is equal to -x plus 6. That has a y-intercept of 6 and a slope of -1. So I graph that boundary line. Now, to determine which side of the line to shade, I've got to test a point to see if it works on one side of the line. So I always test 0, 0. And I always test it in the original inequality. So the first one is y is greater than or equal to -1. Well, we only have a y value to test of 0, and 0 is indeed greater than or equal to -1, so that works. So since 0, 0 is above this line, we're going to shade above that line. So we've got to shade above the horizontal line. When you test 0, 0 in this, you put in 0 for x, 0 for y. This side becomes 0, and that is, again, less than or equal to 3. And that was this line here, and 0, 0 is below that line, so we're going to shade below that line. And over here, 0, 0, we have x plus y is less than or is equal to 6 is this boundary here. We test 0, 0, right, which is below the line here by putting 0 in for x and 0 in for y. And we get, again, a true inequality, which means that all the points below the line are going to work. So we're shading below this line, right? We're shading below this line, and we're shading above this line. So the region that's common to all of those shadings is this triangular region here. That's the region that's above this line, below this line, and at the same time below this line. So it's this triangular region here. Now to find the area of that triangle, we use the formula for area of a triangle, which is base times height divided by 2. Well, the base length of the triangle here is this, and that is 1, 2, 3, 4, 5, 6, 7, 8, 9 units. And the height of the triangle is the vertical height here, which is 1, 2, 3, 4, 5, 6 units. So we get 9 times 6, which is 54, divided by 2 is 27 square units.